With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone, let us start with our question. In this question, what is given that there is a loop ABCD which is moving with the velocity v towards the right. Now the magnetic field in the loop is given as to be 2 Tesla. Loop is connected to a resistance 9 ohm. Now if the steady current of 2 ampere flows into the loop, we need to find what is the value of V. And it is also given that the loop resistance is 4 ohm. Okay, so this is the 9 ohm which is the external resistance, and if we consider this whole loop, the resistance is 4 ohm. Now it is also given that ED is equals to 30 centimeter. So length from here to here, it is given as to be 30. Now we know the current. Okay, so we can say that current value would be equals to I, because this would be the induced current. Okay, because we are moving it in the magnetic field, so there would be a flux which would be changed. Flux would be changed. Due to change in flux, there would be an EMF which would be induced, and due to this, it would be a current which would be produced. So E value, or the induced current, would be equals to induced EMF divided by R equivalent resistance. So first of all, you find what is R equivalent. It is very simple because it is a simple circuit. Okay, so current direction, if we just get the current direction, so magnetic field is going into the plane of paper, denoted by the cross. Now if we just move it to the right, so what will happen? So the magnetic field which is going into the plane of paper, they are decreasing. So what would be the direction of the current? What it would try to do? It would try to increase the magnetic field which is going into the plane of paper. Why? Because while moving away out of the magnetic field, the downward magnetic field going is decreased. So what should be the direction of the current? Current should be in this direction. Now if this is the direction, we can see that the same current is flowing through whole of the circuit. That means this 9 ohm and the series resistance, which is this loop resistance, which is 4 ohm, they would be in series. So we say that R equivalent would be equals to the sum of resistances. 9 plus 14, that means 13 ohm. So we know this, we know the value of I. What is E? EMF, whenever there is a wire which is moved in the magnetic field, we say that our EMF would be equals to, because there are several segments of wire, this segment, this segment, this segment, this segment. So from any of the segment, EMF could be written as the perpendicular component of the magnetic field, which would be perpendicular to the velocity and which is perpendicular to the length. That means BVL, we can just write that we calculate the value as BVL, but here B should be perpendicular. We need to find the magnetic component which is perpendicular, the velocity component which is perpendicular, and L which is perpendicular. That means BLB, they should be mutually perpendicular. Okay, now for this portion CB, so it is out of the magnetic field, so there would there won't be any EMF which would be induced into this wire. Okay, now this CD length, what is the direction? It is in this direction. So what is the velocity? Velocity is also in this direction. This is velocity, this is length. That means there won't be any EMF which would be induced due to this wire. Why? Because these are parallel. We need to find what is the perpendicular distance, or the perpendicular portion of the length. So they won't be having any perpendicular component of the length because they are parallel to velocity. Similarly, we can see here. So there is no EMF which would be induced due to the change in flux. Here also there won't be any EMF which would be induced. Now for this part, so it is at an angle of 30 degrees. Now if we take the perpendicular component of this part, so this value is given as to be 30 centimeter. That means 0.3 meters. So this parallel component would be 0.3 cos of theta, but perpendicular component would be 0.3 sine of theta. That means 30 degree. So due to this length, okay, so due to the projection, or we can say the perpendicular projection of this length AD, there would be an EMF which would be induced. So the only EMF induced would be due to this length. We call this magnetic field as B. 2 into V value would be V, we don't know. L value would be equals to 0.3 sine of 30. So 0.3 sine 30 degree is equals to 1 divided by 2. Now we can put all the values into our equation 1. Now current value we know, it is given as to be 2. EMF is 2 into V into 0.3 into 1 divided by 2 divided by R value. Resistance value we have calculated to be 3. So this 2 and this 2 would be gone. So V would be equals to 13 into 2 divided by 0.3. So if we solve this, then our answer would turn out to be 86.6 meters per second. So which is the correct option? 86.6 or approximately equals to 86.7. A would be the correct option. Hope you understood this solution. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut app today.